Morning, Wes.
Looks like we got David and Lori and Magnus, but I don't see Martin.
Okay, I see Martin now. We probably ought to get started.
Can you hear me from Aberdeen?
Yes, indeed.
Excellent. Good morning.
So this is the TSVWG second meeting this IETF week, and David, Gory, and myself are co-chairing. The IETF note well applies to this meeting. And to get started, we need, I think, to find a note taker, and if we can, a JabberScribe would be helpful. I think Michael said he was not able to do the JabberScribing this session that he did last time, so if someone can take his place, that would be great.
Michael did notes last time. We need a note taker, actually.
Oh, yes. Note taker is what we really need. I'm sorry. And Brian will do notes. Okay, but we need a backup. So can someone volunteer to be a backup note taker, and then we will have Brian be the primary.
Is Brian taking it in the meeting too?
I see Jake volunteered to be the backup.
Excellent.
So that looks good. All right. As always, it's good to get people to review the working group drafts. We have a few that need reviewers right now, and we'll talk about these today. For future draft authors, just remember to add the TSVWG to the titles of any internet drafts you submit, so they'll show up in the tracker properly. And slides are advancing wrong. Okay, so we're using Meetecho for this meeting. It may be easier to use separate tabs to view the Jabber discussion and keep separate meeting notes if you're the note taker. In discussion, please use the icon of the hand plus mic in order to join the queue, and then the chairs grant the floor. And the triangle mic icon sends audio immediately, and that can cause trouble. And don't send your video on Meetecho. We will share all the slides from the chairs' computers. The agenda today, I don't know if we have to bash. Can someone help me? Did we get anything for the UDP options topic that we moved from Tuesday?
Corey, have you heard from Joe?
Yeah, I'm trying to get my mic. Can you hear me now?
Yes, we can.
Excellent. Yes, we have slides from Joe. They're in the proceedings. If somebody can show them, I can talk to them.
Okay. I have a copy of those at the moment, so maybe, I don't know if we can switch to you, David, to show them.
Let me make sure I've got them. Hang on.
And then we also have the NAT for quick draft that we'll briefly discuss at least. And then there are a number of drafts on L4S that we're discussing. First with a status recap on open issues, then draft status on the latest updates, and then we want to talk about plans for the TCP Prague and L4S operational guidance drafts. And finally, there are some new drafts on, well, in general, related to the topic of data center congestion control. There's HPC C++ and PFC free, and we wanted to give a chance to let the authors introduce both those drafts to the working group, and then have a combined follow-up discussion, since it seemed to the chairs like this is a general topic, and we've actually had more data center congestion control drafts in the past that have been brought to the working group and have not been adopted. So we're trying to figure out what the working group's interest is in this area and what we should be doing. So I think it's time for the UDP options draft.
Yeah. Oh, and there they are. Way the heck down the bottom. Okay, hang on.
Do I have to unshare so that you can share?
Just a minute. I need to go. Still negotiating with data tracker. Give me a minute. Okay. I should be able to send this now. Hang on. Okay.
So where did you find those in the proceedings, David? I'm trying to put a link in the slides.
They were sitting on the meeting materials page. And
Yeah, they're at the bottom.
At the bottom of today's.
Yeah.
Yeah, Wes,
Okay.
I think you need to stop sending your screen. All right, let's see if I can get it to do it. There we go. All right. Hang on. I believe we want that one.
All right, they're not in my data tracker, but we'll fix the link in the notes later.
Okay, I saw them in the meeting materials page. I did not see them when I brought up meeting materials on the agenda page.
Okay, got it.
So
Okay, yep.
I think
Got it.
I think the data tracker has gently hidden them, and we're going to have to go have words with it.
Cool.
Okay. I think I've got slides up. Gory, can you see them?
I can. Maybe I can start.
Why don't you go ahead and start? Tell me when to advance.
Okay, so good morning. I'm not Joe Touch, but I'm presenting slides that I've discussed with Joe Touch. So hopefully I can represent them and tell you about UDP options. I don't have any palm trees outside my window. This is Joe's view, not mine. Okay, these slides were only uploaded this morning ahead of the meeting, so they'll probably make them through to the proceedings automatically in a few minutes. We can see them, but you might not. They talk about a draft that you can't see also. They talk about draft 9, which is the draft that Joe's working on. This contains pending edits from discussions at IETF-106 and follow-up, and a number of changes which the working group has kind of been bashing out for a while, and Joe is now producing text for. The important changes are to FRAG, which now removes the specific UDP light equivalent option and creates just a FRAG option for doing fragmentation. This is an attempt to significantly simplify the amount of things you have to process to implement UDP options. The ACS has changed to a CRC 32C, which I think we talked about in the working group many meetings ago and came up with this, but has finally made it through to the text. We also talked about trying to make the OCS header a way in which UDP options would be processed by NATs. In other words, they would get forwarding by the NATs and with a checksum that actually worked. So this was done using the OCS pseudo header, and that's been updated to reflect what's needed to get that NAT traversal property. We also talked about the possibility of having options which were necessary to process before the packet was forwarded. So this creates required options that has to be understood to be interpreted. And Joe's incarnation of this is the unsafe option. Finally, there's a motivation to deprecate 6081 to remove flaws that would interact with UDP options. Next slide. So the new option processing rules have taken the most time to thrash out, and they result in a new understanding of how to process options. In general, an option is processed and nothing happens if the option is not understood, processing continued. But there are two particular options which cause a failure to process the option and a failure to receive the packet. These two options are the OCS, when the checksum fails, the packet is regarded as invalid and is not forwarded, and the FRAG field, where obviously there are semantics here that have to be taken to result in a useful packet. Joe also added a new type of option, a sub-option called unsafe. And if you send one of these options and you don't understand it, then it's treated specially. Other options are simply ignored. And this has to be placed before the FRAG option to make it work. So next slide. The new FRAG option has to be read. So you need to see the next version of the draft to understand this. Let me give you a quick preview. It's used only with zero length user data. So there is no actual data part when the fragment option is used. This is to avoid misdelivery on stacks that forward part of the space upwards and would result in a very strange partial delivery. So you can't use it with any user data. It allows a single fragment packet per UDP option packet, and it retains the zero copy approach because this was thought by Joe to be important, and he motivated that at the last set of slides that were presented at the IETF. Next option. Next slide, sorry. The FRAG format looks like this, which I'm sure you can't read because I can't read, but I can on my copy of the slides. It basically defines one option for intermediate fragments and a final option for the non-terminal. Wait. It defines a special format for the terminal fragment of a chain of fragments and one for all the other fragments, a bit like the more field when that's used. And the new result has the properties of being like UDP light, but only for fragments. Read the draft when it's published to the IDE repository, please. Next slide. This is the unsafe class of options. It's a subkind, and these options have to be implemented or the processing has to be performed in a way which is safe. So it describes an option that is required in some way to continue processing of the other options. It's got variable length, and again, it will be described in the draft. This fixes the issues, or tries to fix the issues that were raised by Tom Herbert and Magnus and other people on how to make the system evolvable to support new options which weren't known at the receiver. Next slide. There's now a classification of options that needed to be implemented by a conformant spec and those that don't need to be implemented by a conformant spec. Obviously, you can implement all the ones you wish, but the first set must be implemented. And this includes the new unsafe options so that we have ability to upgrade the set of options that are in use. It continues the MSS option, which is the one that's used by PathMTU Discovery, and it includes NOP, end of option list, OCS, and ACS, as well as FRAG. Next slide. There is an issue with RFC 6081, and this slide simply highlights it. It notes that have an issue when they propagate the UDP packets, and this interacts negatively with the way in which UDP options are defined. So Joe will include text in this that seeks to deprecate this way in which UDP option space is handled. Again, we probably need to see that to know as a working group whether this issue is one that we should indeed deprecate, but there's good indications that this was actually a mistake in the way it was defined here. So this is the set of slides that Joe's volunteered. It's very much a statement of intent, and I know that Joe has said he will prepare a new revision soon to keep this process going and let other people read the changes that he's made. Any comments?
Oh.
Well, in this case, I hear no comments is good, and I encourage people to read the draft. Putting on my chair hat, this is something that other people in the IETF has been mentioning, for which the working group has had pending questions and things to resolve. And I believe that Joe will be working in the next few weeks to get that new revision uploaded so we can look at it. And it may clear all issues, perhaps, I don't know. So please read it and see if you have further issues with the draft.
We can be optimistic.
I was being optimistic. The palm tree. Okay.
Okay. Next up, I think we have a brief update from Martin on the NAT for quick draft.
Good morning, afternoon, everyone. Yeah, I don't have any slides. Some of you may recall I briefed the very short, quick NAT draft at 107, or the interim that was 107 for us. And I got some interest from here and the suggestion I should take it to quick. And a couple of minor editorial comments. The editorial comments, somewhat late, have been, there's a new draft that dropped yesterday that reflects those comments. I did not make it onto the quick agenda, and so very little has happened regarding this draft. My intention is still to run it by quick, see if they want it, and then maybe take it back here if the working group is still interested in taking out that draft. That's it.
Okay, Martin, thanks. I guess this follows the long series of behave-like documents which we've had in this working group, and we'd like to see updates of this draft presented here as you go along.
Okay, it was a very minor update.
Yeah, that's fine. No, I didn't mean.
Yeah.
No, I meant updates on the process, on whether quick takes it, on what your intentions are.
Okay, thanks.
Thank you. Thank you for giving us the feedback there. Has anybody got any questions that they want to raise, or any queries, or think this is not a document we should be working on? Please come to the mic if you have any questions.
Okay, seeing nobody, I think we move along. Status recap on the L4S drafts, I believe, is next. Wes, this would be you.
Next, David.
Okay.
So I wanted to take a small amount of time in the meeting just to remind people that the way we've been working this suite of L4S drafts, we took the issues and have been adding to them over time from a few meetings ago, and through additions and closures. At the moment, we've got 12 open issues. We would like to take some time today to go through a small number of those that I either picked because I thought they were the most important, or the closest to being ready to close. And so in terms of working towards the working group last call, I think these were some important things to talk about today. The issue on ECT1 was strongly linked to a number of other issues, and we did close that since the last meeting. There are several other that on the mailing list we've been talking about possibly closing, but they haven't really seemed to converge on that, so we haven't closed them. Others, I think, may be awaiting smaller editorial actions or other types of follow-up, and I think we need to be clear on what's expected in order to get these closed. So you go to the next chart. So the one that I think is probably most important myself as a draft shepherd is this issue on number 16 on interaction with RFC 3168 only classic ECHN AQMs. And we've had a lot of discussion on this on the mailing list. The classic bottleneck detection work seems to be very interesting. I think it's progressing well. There's nice measurements available. It doesn't work perfectly all the time. And at present, the sense I get from the working group is that this is not safe to rely on all by itself yet, although it looks interesting to keep working on. If I've got this wrong, please let me know. There are also a number of additional or alternative things that Jake nicely enumerated on the mailing list. These could be sort of a belt and suspenders kind of approach to enhancing classic bottleneck detection with some other mechanisms that even when classic bottleneck detection doesn't work, it makes L4S still safe. So I didn't see a lot of follow-up to Jake's nice list from people saying which of these ideas seem like promising ones to pursue, or really get a good sense of what the next steps are towards getting this issue addressed. So I was hoping that the editors or others with strong feelings about this would let us know what they're thinking. I would love to hear that right now, if it's something people want to talk about.
Greg, go ahead.
Hello. So a good summary, Wes, on this one. I have actually just 25 minutes ago uploaded a first draft of an L4S operational guidance document that was inspired by the list that Jake had sent includes many of those ideas. Doesn't include every single one of them, but includes some others as well. And it's a very early draft, but hope is that will progress. Actually, I have some slides on that a little bit later in the agenda. But I think that's one component of addressing this issue, and there may be others. Thanks.
Okay, Jonathan?
Okay. I have seen that draft come up on the mailing list that Greg just mentioned. This is Jonathan. And I've only been able to read it briefly in the past few minutes. I do notice that most of the options seem to rely on operators that currently run RFC 3168 bottlenecks becoming aware of or actively aware of L4S existence and making network changes to do so. This is a concern to me, but we'll see what everyone else thinks, I think.
Yeah, the draft's just been submitted, so more discussion on the list. And I think Greg's got some slides coming up that will explain his approach to the draft.
Yeah, and it looked like Bob was in the queue for a second, but left. I don't know if he wanted to say something. Okay, great. Greg said it for him. All right. Okay.
That's what I was hoping the explanation was. Okay, next slide.
So hopefully this is an easy one. If you remember in the past, we had some terminology discussions about trying to make sure traditional, classic, and legacy were either not used or used appropriately wherever they're used, and also to reduce hype in the drafts. And it sounds like we're almost there. I think Bob noted that, and Greg originally noted that legacy still appears a few times in the architecture draft. But other than that, it looks like the editors think the job is done here, and we've proposed on the list that the rest of the working group should verify that. And other than the few instances of legacy that might need to be fixed up, we hope that the response is that this one is done. So this is just a notice to the working group to go find that thread. And if you had issues with hype or terminology, see if they have been addressed.
So I would chip in here that this is something that we can continue to do from now on as these drafts mature, just to make sure that we're selling the technology in a spec rather than as an advertisement. So please comment on the list if you see things, or send notes to the authors, and I'm sure we can make sure the final document meets those requirements. Go ahead, Wood.
Okay, and then another one that may be very close here is the one on admission control or untrusted marking. That's number 26 for those of you who use the numbers. So the basis of this one is that there is some discussion in architecture document about use of a queue protection function. It's not required, but it is helpful. And there's a draft that describes how this is done for low latency DOCSIS, which is referenced. And I think we said in the last meeting earlier this week that that draft is planned to proceed as an independent submission. So to me, this one looks like it's close to being ready for closure, and that there's a good specification of the mechanism that addresses this, but it seems like there is still an open issue, sub-issue to it about whether the queue protection function actually needs to be required or whether it can remain optional. And I wasn't sure if the mailing list threads actually ended with any agreement on this. It didn't look like it to me. It looked like it was still question or doubt in people's minds. And I wondered if that's the case, is this something that can be within scope of answering as part of this L4S experiment? Does it really need to be answered before the drafts are done? And that's basically something I was hoping the working group might answer on. I don't really understand to people what more will be done here, how we expect the documents to change, other than this question of whether queue protection is mandatory or not. And that didn't seem to me to be something that we needed to even answer right away before finishing the experimental specs. So if people have thoughts on that, I would really love to hear them.
The related question of what needs to be done in the way of queue protection, traffic protection for the NQB PHB will have to be answered there. These two questions are obviously related. Bob, go ahead.
Hi, can you hear me first?
Yes, loud and clear.
Right. Turns out that pausing the screen share seems to make things better. Right. The question of implementation, whether the implementation of queue protection is mandatory. I've got a question for you, David. Is policing mandatory in DiffServ?
I'm going to answer that question in the context of NQB, where it looks like policing is necessary in full generality.
No, that wasn't the question.
I'm not going to answer that question.
Yeah.
Well,
the question was, when DiffServ was standardized, I thought 2474, the main DiffServ draft and all the different PHBs and things were all, standards track and all the rest of it. And the architecture and the policing and everything was all informational.
I think this might be digging in the wrong place. The crucial question, which also the question has to be answered in terms of NQB, is, do you need this functionality to assure delivery of the service as specified?
But that's why I'm asking about DiffServ, because it's the same.
I'm asking about what tools does an operator need to get the job done, and you're asking about what did a long ago written set of RFCs say. I don't think they're the same question.
Okay, right. Anyway, I've started to, when I saw this come up on Wes's slides, when I looked at them, I started to write an email about this. So there'll be one on the list soon. Right.
Okay.
So.
I take 2474 as saying, reading from it, in addition, the forwarding path may require that some monitoring, policing and shaping be done.
Yeah. ... Yeah. So I don't think it's a DiffServ framework question. I think it's a in DiffServ terms, it would be a PHB question, except that the L4S low latency queue is not a PHB. And so I think it comes down to what are the tools that an operator needs to effectively deliver the low latency service. And I think I agree with Wes's suggestion that some of that might be questions to be answered by the experiment, but that requires carefully scoping the experiment, explaining what's going on.
And that's probably what my email was going to say, is that when you go back to the slides we had to provide the chairs at the April interim, the summary, sort of number one was that L4S was aiming to work without per flow processing, and it's all been designed to not do that. And so the experiment is that possible? And so if then it's mandatory to do per flow stuff, becomes sort of pointless. The whole thing becomes
Well, I
not what
understand
the original
design.
experiment was. Yeah.
Right. So, well,
Yeah.
If the experiments, let's see, this is a lot easier to deal with in the context of the NQB PHP. But I think we would all agree that if we see lengthy queues being built in the L4S low latency queue so that it doesn't deliver low latency, that would be a bad outcome. What we have to do to figure out whether that's a possibility and provide tools to address it, I think that goes into definition of the experiment. I understand the design intent. The problem is that you've got this very attractive, ooh, if I send it this way, it goes faster opportunity.
No, that's the point. It doesn't. If I send it this way and I behave, it will be low latency. If I don't behave, I will not get low latency because the high latency is caused by me. So there's no that's the whole issue about incentives.
And
let's move that to the list. I think,
we move offline because it's not that simple. I wish it were.
Right.
Okay, next slide. I think yes.
Yep.
All right. Greg, did you want to say a couple words?
Yeah, I was in the queue, and it was really mainly on the NQB aspect, and I realized that yesterday or Tuesday I did not articulate what my thinking was on requirement for queue protection in a QB. My intent is to flesh out the section that discusses traffic protection as being a should and the ramifications of not implementing that should. I think ensuring that NQB works well is or can be managed in a couple of different ways, and one of them could be traffic protection, but there are others, and the intention is to articulate what some of those other options are and the ramifications of not doing it, even if you don't do some of those other options. So,
yeah, we need to have that discussion on what alternatives might be if NQB is not present in the equipment in the context of NQB, and maybe that will inform this discussion in the context of L4S. We can be hopeful. Bob?
Yeah, and one of the other points is that in the architecture document, one of the points of L4S, and particularly the dual queue aspect of L4S, is that it's designed to be simple enough to be eventually put in all sorts of queues, not just the bottleneck queues. You know, it's primarily needed in the bottleneck queues, but it could end up in hosts, in core equipment, and all the rest of it. It's potentially simple enough to do that. And there, you wouldn't necessarily want to be putting in queue protection. So, you know, if there was some mandatoriness to it, I don't think everyone would want to have that mandatoriness, or whatever the word is, apply wherever you implement it. Because sometimes it's just in case a node becomes a bottleneck.
Yeah, and that's a much longer discussion. Because just in case is certainly a very familiar design paradigm from the security area, where things are mandatory to implement so that they're present if needed. And I think with that, we really do need to move on to the next slide.
Yeah, okay.
Yes, I don't want to eat up too much more time, but this is a, I guess, warning. I'm going to send some mails to the mailing list to see if we are ready to either consider some of these issues to have been taken care of in the case of number 19, or to basically deduplicate with other issues, or link to other drafts in the case of number 21 and 29. So I don't need necessarily to get input on that today because we're running short on time, but I'll start mailing list threads on all of these very, very soon. And you could go to the next chart because I think this is the most important part. I wanted to know if people want to have any more interim meetings to go through issues and make progress, if that was helpful, or if people didn't find it a good use of time. Just curious, because we have, like I say, 12 issues, and mailing list is sometimes difficult to make progress on. So if there are any thoughts on that, please let us know.
Okay. Hang on. Where am I? Okay. Not seeing anything in the way of comments. I think we're going to move on. Bob and everybody else, you've got about half an hour, perhaps a bit more. At about quarter after, we're going to start trying to shift over to the data center related congestion control topic. Let me make sure I use the right words for that. Hang on. Yeah, data center control topic, as we want to provide a little more than half an hour for that towards the end of the meeting. So with that, here's first slide deck. And let me know when to advance slides, please. And might help if I let Bob speak to his slides. That would be a really good idea. Go ahead. Bob, if you're speaking, we're not hearing you. Oh dear.
Is that better?
Yeah.
There we go. Here he is.
Yep. As I said, but you didn't hear me. I've paused my screen share, so I don't know what slide you're on, because that's the only way I can get my audio to work.
I'm on your title slide. When you call advance, I'll call a slide number.
Yep. Please advance. Yep.
Slide 2.
All right. Just a quick recap for anyone here who doesn't know what L4S is. One slide. It's an architecture which stands for low latency, low loss, scalable throughput, to aim to get ultra low, meaning about 1 millisecond or under 2 milliseconds at the 99th percentile for all internet applications, including capacity seeking TCP-like ones, capacity adaptive ones, not just what you might call unresponsive, to get low latency. And it does that by essentially making the saw teeth of TCP a lot smaller, which makes it more aggressive, and that's why we're having the problems we've all just been talking about. That said, I'm not going to do any more recap. This is going to go straight in, assuming you know what's been going on and been following everything. Now, slide 3.
Slide 3.
Right, just some news on implementations. These are all the network part, and they're all to do with the dual queue coupled AQM, apart from the OS3 one, which I'm going to cover on the next 2 slides. The first, Broadcom have released to a selected audience, at least, a new integrated packet processor and traffic manager, which is their part of their Strata DNX product line, and that includes the L4S dual queue coupled AQM. So that's a high-speed switch chip that is intended for very high density ports, and I think the whole switch goes up to about 0.7 terabits per second, something like that. The backplane. The chips are capable of being used in that environment. So that's an interesting bit of news. Low latency DOCSIS news. In the DOCSIS industry, in the cable industry, there's been interop testing of 3 independent implementations, 2 cable modems, 1 cable modem termination server, and they're largely passing all the tests, but not completely passing. That's the functional tests. 1 implementation has passed them all, so there's progress there. Data plane development kit, that's another interesting development. It's an open source library to accelerate packet processing in a variety of CPU architectures. It was originally Intel, but it's wider than that now. And this is not news that it's happened, but it's planned to implement the dual queue coupled AQM. That work has recently started. And finally, NS3, if we move to slide 4, please.
Slide 4.
The NS3 Prague implementation has been improved, and the aim is to try and completely mirror the Linux implementation. So Linux-like pacing has been added, pace chirping, or Reno flow start has been added, and support for RTT independence. So the aim of the NS3 team is so that as problems get identified, that NS3 can be used to drill down into what the problem could be and solve it. And that's only possible if NS3 is sufficiently like one operating system and they've chosen Linux to be able to do that. So that's very important for testing and verifiability and all the rest of it. And this slide is courtesy of Tom Henderson, who leads that NS3 effort. And there's 3 summer students working on L4S related models in NS3. There's the improvements in TCP Prague above, including AQCN, accurate ECN, validation and alignment with the Linux implementation again. There's an L4S aware FQ has been written to mirror the Linux one. And there's an FQ Cobalt with L4S being worked on. And then the next step will be to integrate in AQ filtering, which already exists. I'm getting some background noise.
Yeah, I went into the mic queue.
Ah, okay.
Right. So I'm just like to ask if you're aware of Mohit Taliani's effort on making an FQ Cobalt implementation for NS3.
Yes, yeah, these are that's very much what we're talking about here. Well, I mean, Mohit's students are working on that, and they're working with Tom, and Tom has also got some summer students working on it. So it's all one. Tom is on top of all that, if you like.
All right.
Yep. Okay. Shall I move on?
5.
Hang on. Oh yeah, and the generation of Flint compatible experiment traces is intended to come out of that. Okay. Next, slide 5. So the hackathon work last week and this has also focused largely on NS3, but there's another bullet. And so a lot of progress on RTT independence, the FQ Cobalt work, the Flint work. Tom's been integrating that as well. And Tom says it's on track to include most of those components and the dual queue coupled AQM model in the 3.32 release in September. And then the other hackathon work was 2 students from New York University, actually a postdoc, I think, and a PhD student, documenting and scripting how to experiment with L4S in Cloud Lab. And they've been reproducing most of Peter Heiss' scenarios and posted all that on GitHub. And you can see the details of all that at that link there.
Okay,
move on if
slide
there's
6.
no questions. 6, yep. So now quickly on to the drafts, the status of the drafts. We've just been talking about the architecture draft. It's largely, as far as I can tell, complete. There's this legacy words that we've got to change that were after I wrote this slide. And then the only other thing is that currently the reference to FQ Codel with L4S support is to the code, and really just it would be great if someone would write a draft to document that. Maybe one of those students who just implemented it, and then we could refer to that as well as the code, or that could refer to the code. So that's an open invitation to someone to do that. The dual queue coupled AQM, again, I think largely complete. Just recently posted a new version with very minor edits to take account of some of the points that the Broadcom people identified in the appendix about curvy red, because that's the first implementation of curvy red, where there was a mistake that I take responsibility for, but fortunately they assumed it was a mistake in their implementation and allowed the other way round than I said. So fortunately the chips don't include that mistake, or they can be worked around, and they have now worked made the non-mistaken version the default. So that's good. And the L4S ID, I think, is the one that still needs a bit of work. Sorry, the ECN L4S ID. No changes since the April interim, I'm afraid, and that's down to me. I've essentially just had a bit of burnout after that, and I'm now feeling back on top of things. So I still haven't done documenting Jake's proposed approach, so I'm on the hook to do that. And the next slide, I want to discuss some of the shoulds and musts, or two of them in particular. So can we move to that?
Slide 7.
Right. The one about remaining responsive at low round trip time. The idea of that one is that we discovered that when you take out the queuing delay, which acts a bit like a cushion, when you get very low queuing delay, you more often hit TCP's minimum limit of a two segment window, and that effectively makes TCP unresponsive, and this is particularly at low round trip times. So even though you may be going reasonably high speed, at low round trip time, you can still have a low enough window to be lower than 2 packets. And so my colleague Asad Ahmed did implement a solution to that. It's reasonably simple, but a fair deal more complexity in order to be able to have a window below 1. And at some point in ICCRG, we'd like to give a talk on that. But as a result of that work, I would like to propose that we change that must to a should, and possibly even a may. And that's because what we found is that maybe the scenarios where that happens are relatively rare. You usually need quite a few flows in parallel. And you also lose what one might call the inherent protection against unresponsive flows that a minimum window gives to your own flow. It essentially says, I stop being responsive if you push me right down to nothing. And that, so I think there's maybe a debate to be had on the list about that, but or if anyone wants to, but I've changed it to should in the draft, and I'm wondering whether we ought to recommend not to do it, which would be a may more than a should. Anyway, I don't know whether anyone's got anything to say about that, or if not, I'll move on to the next one.
I'd move on. My immediate reaction is I'd like to see the ICCRG discussion.
Right.
Bob,
yep.
Gori here. Can I ask a question just from the floor? I mean, did this must come from the L4S work? Because I don't see equivalent things in TCP as a must.
Exactly, and that's because TCP doesn't ever have such a small queue. It, it induces this larger queue, and so even if you've got a low round trip time of 2 or 3 milliseconds, you end up with a total round trip time for a long running flow of maybe 15, 20 milliseconds, and then you don't see the problem. So
Right.
it's only once
Right.
we started removing that queue
Right.
that
Quick
we
warning,
discovered
there's-
there was a problem.
Yeah, quick warning. There's about 20 minutes to go before we're going to try to start switching over to
Okay.
data center congestion control.
Okay, we're nearly there. There was a 20-minute slot for this, and I don't think I've used it, so I'm hopefully going to give you some time. So the other one, the fallback on classic ECN AQM detection. Obviously, this all depends on this discussion that Jonathan just indicated, and Greg's going to talk about next. But preempting that a bit, maybe a better way of writing this requirement for the L4S experiment is that the implementation must be capable of, rather than must, and so this is a must implement, if you like, of monitoring for classic ECN AQM and logging the results and falling back to Reno friendly if detected, but that it should be possible to enable each of those independently. So you could monitor and log so that maybe your CDN operator can find out whether there are problems a bit more lazily than within each connection. So if you turn off the fallback, you don't get the false positives, but maybe, so there's various ways of dealing with it during the experiment, but you've got the code there if you need it. So that may be one way to solve that problem, but a known issue with that formulation of text that I haven't been able to sort out is how to wordsmith it so that a CDN operator that wants to deal with this preemptively before they deploy L4S by doing some monitoring beforehand would have to still implement fallback within the code as well if they wanted to comply with this spec, and they probably wouldn't want to do that if they'd already sorted out the problem beforehand. So there's some wordsmithing to do there.
Okay.
Any
Slide 8.
Slide 8. Right. So I'd like to relaunch the invitation to get involved in L4S to encourage more implementations, more testing, more repeatability. We're starting to see more of that happening, particularly from the university and student environment, as mentioned earlier. And you've seen there's also the corporate environment are doing more on this, but more on the network than the TCP Prague side. And there are 4 different ways of interacting. We want to try and get the TCP Prague list used more for all L4S congestion controls, not just TCP. So quick and all the rest of it for detailed discussion of that. Really detailed code-specific issues. Please, do pull requests on the GitHub. The TSV list obviously is for discussion of these drafts, and ICCRG for any pre-standardization discussion of congestion controls. And that's it.
So we have a couple of notes in Java, which maybe should be relayed. And Mira says +1 to remove the must requirement. And Jonathan
Which one?
Morris, +1 to remove the must requirement.
Yeah, which must requirement? Because I talked about 2.
Probably the first one.
Right.
Unless Mira says different, it's that.
Mira says the first one.
Yep.
Okay. Jonathan follows up. It probably makes sense to allow effective send rates to drop below 2 per RTT. So same one. Via pacing, but to keep C-wind greater than or equal to 2.
Yeah, my general reaction is I'd really like to see the ICCRG discussion on that.
Okay.
All right.
We haven't discussed pacing in any transport groups much, really. So that sounds like an ICCRG discussion, I think.
Mm-hmm.
Yep.
Okay, that was the feedback from Java.
Okay.
All right. Title slide for prod congestion control is now displayed, Bob.
Okay, yeah. This is a brief presentation of a draft that doesn't exist yet, but we were asked.
Right, and you and Greg have 15 minutes.
Oh, okay. This shouldn't take that. So if you can move to slide 2.
Okay, slide 2.
The draft name on the title slide doesn't exist yet, so there's no point remembering it yet. It's currently in a GitHub, so you can go and look at it if you want, where you have to compile the XML. The background to this is that the Linux reference implementation of TCP Prague congestion control was implemented, and there's the GitHub link, in the last TSVG interim in April. We were asked to write up that as an internet draft, and we've written the body of it, which you can see in that different GitHub. As I just mentioned, the XML is there, and hopefully it will be posted by the end of this week. Essentially, the body is written, but not the top and tail. So it's sort of reviewable if you're not interested in introductions and conclusions. In this presentation, I just want to highlight the choices that have been made, the top level choices, and how we want to work. So next slide 3.
Slide 3.
So there are 4 choices here that we had to make before writing the draft. Do we want to write one about TCP Prague or just about Prague congestion control in general? And we decided Prague congestion control in general, so yes, independent. But we also have put in specifics for the main transports where they're different. Like, for instance, TCP has to use accurate ECN, but if you're talking about quick, it's already got that feedback inherently. And hence in the title, it's Prague congestion control, not TCP Prague congestion control. So the next choice, which working group should we work on, should we use for this? And I would propose ICCRG, because that's where the review expertise is for congestion control. I asked just the chairs of TSVWG and ICCRG, and they both agreed, but we'll need ICCRG adoption call to approve that decision. You know, it's not something the chairs or me can decide on our own. And then the next choice, should it be implementation independent? And definitely yes. That's the whole point of writing a spec as opposed to code, is to try and tease out the parts that are implementation independent, so that other implementations can be written under other operating systems. But we have put in copious implementation notes, mainly from our Linux experience. And obviously the main difference between, say, Linux and FreeBSD is the per packet versus per byte handling of congestion windows and things like that. The final choice, which I think is more changeable later, but it'd be nice to be able to write the draft in a style that doesn't have to change later if we can. And that's between whether you write it as a normative experimental track type draft or an informative informational track type draft. The first being more designed to encourage others to write their own implementations, so they know exactly what they should and must do in order, what's important to repeat and what they've got freedom to do differently. The informative one is more, this is what it is, this is what it is like. So I think the experimental one is maybe more useful and more the point of what we're trying to do here, to encourage others. But as you'll see in the following bullets, when I tried to write it like that, it got a bit sort of unnatural, with lots of musts and shoulds in it. And so one possibility, one proposal is that we keep it on the experimental track, but we just have one normative statement saying you must comply with the requirements in draft IETF ECN L4S ID, and then just describe how it works. But that's going to be necessary to see the text.
I would take the discussion into ICCRG and see what makes sense.
Yeah. Okay. And then the way we want to work, we definitely want to give out the message that one true way is not the intention. In other words, we're not trying to document the only Prague congestion control, and certainly not the only L4S congestion control. for a start, Prague congestion control is intended to be a set of components. So you might have a different slow start on the front. You might have different ways of doing the EWMA and the moving averages and things like that. And so this is more intended to be a bit more like a set of parts, and it's certainly expected that there will be other Prague or congestion controls that satisfy the Prague requirements or aim to satisfy the requirements that are in a completely different family than trying to be a bit like DC-TCP. For instance, maybe like relentless congestion control or something like that, that don't don't inherit from DC-TCP. So this is really documenting, this draft is meant to document the DC-TCP family, if you like, of Prague congestion control only. And we expect the evolution of this will proceed as the L4S experiment proceeds. So the body of the draft is structured for two main parts. That's the Prague congestion control, and the more stable parts of it, and then variants and future plans and things in a second main part. And again, just I don't need to repeat the bottom part, which is the places where this will be discussed. Very similar to the previous slides I said, except this is now congestion control, so it's ICCRG is the primary mailing list.
Okay. Slide 5, Q&A and spare slide. Okay, are we done?
We are, as there's no Q&A.
All right, we have a question. Rui, if I pronounced your name correctly, go ahead.
Oh, no, I thought I joined for the next session presentation.
All right. You're not, there's one more coming before that. Any questions on this?
Anybody got any opinions about whether this is a useful thing to do?
I will add that there's a section on pacing in this, which is, relates back to what we just said. We have changed the pacing from DC-TCP quite significantly.
So this is Richard. I just wanted to say that I believe having a protocol independent congestion control defined and have that on a standards track, meaning initially as experimental, like Bob just laid out, makes more sense than doing it on an informational track only, at least to me.
That was Richard Shefniger at the mic.
Yes.
And people talking at the mic should say their name, because not all people have the same tooling up and it can be quite confusing. Jana would like to say something at the mic.
Hi, Jana Iyengar. So I haven't read the draft, and I should probably read the draft to make a judgment. But yes, I have agreed with you that this probably belongs in ICCRG. Is this intended to be, from the sound of it, it sounds like it's intended to be more of a framework and less of a specific congestion controller. Is that an accurate characterization?
Yes and no. It's a statement of what the defaults are, what the core concrete parts are, but some can be optionally taken out and other bits plugged in. So it is one thing, but it's also got some options. Do you see what I mean?
I see. Okay, so it is going to be a specific thing, but it's going to be effectively componentized.
Yeah.
Okay, that makes sense.
Okay, summarizing a bit from the mailing, from the chat, there's several people say it's useful. So that's a useful input, although people probably have to read it. Gori, first, I'd also like to add that this is not an attempt by the chairs to kind of push this away or sideline this in any way. So we are working with Jana, so we will try and find the best place to do this work. Go ahead if anybody has more comment.
Seeing none, let's move to the operational draft. Greg, you have your 5 minutes. Let me know when, and know you're not going to present all 17 slides, but you knew that.
Right. Yeah, there's quite a bit of backup material in this deck. So you can go on to the next slide. I already actually gave a bit of a intro to this earlier in the agenda, but in case folks join late, the intent is to document discussions that have taken place on the list and any additional contributions from others around operationalizing L4S, and in particular, this specific issue of coexistence of L4S traffic with classic traffic in particular bottleneck link types, which this table summarizes 6 different types of network bottlenecks, depending on what AQM is implemented or not in that bottleneck, as well as what kind of scheduling, whether it's dual queue or FQ or just a FIFO. And then the expected result with when L4S flows and classic flows share that bottleneck. And so the one that's been a concern is this classic ECN FIFO, the prevalence of which is not well understood. I think the studies that have been done have not pointed to significant deployments of them, but also have not been able to prove that they don't exist. So there's certainly the potential for them to be present in the internet and in the path that traffic might take. And in that situation, we get scenarios where the classic flows get less throughput than the L4S flows. And so that's what we're wanting to guard against and help avoid with this draft. So next slide. Okay, so I think I've actually already said most of this. So motivation is to ensure reasonable fairness between these 2 categories of flows as they're sharing a bottleneck, minimizing the likelihood of those problems occurring in practice, and then when and if they do, facilitating resolution of those. And we've kind of, in some offline discussions, broken this down into 3 categories of potential guidance that we could provide. One would be around proactive steps that can be taken as an operator of a network or operator of end host begins planning their deployment, things that they can do to prevent the issue from occurring to begin with. Second category would be real-time reactive, which would be as flows are actually running on the network, monitoring throughput, monitoring for ECN marking, and trying to detect the RFC3168 bottlenecks, and then falling back in real time. So that's been discussed quite a bit on the mailing list and in previous discussions. And then a third category of reactive but not real-time reactive. So addressing any problems as they arise via management intervention. So maybe shutting off L4S functionality on certain paths or in certain networks if problems arise. And that one, there's a note that assumes that L4S is safe enough that the reaction does not have to be immediate, real-time, and can be resolved reasonably well with management intervention. Okay, next slide. So the target audience here is, and this is essentially an outline of the draft as well, broken into 3 entities who could be involved in helping manage the situation. One would be the operator of the L4S host themselves. So as they're deciding whether to enable L4S or not, guidance on that, as well as references to features that Bob discussed around detection in real time. Second one, operator of a network, and this would be primarily networks that are implementing RFC 3168 ECN bottlenecks, what they can do to mitigate any potential issues and make the experiment run better. And finally, researchers who could look end-to-end and detect or attempt to detect whether those bottlenecks exist in the first place and potentially where they are in the network, and then comparing performance between Classic and L4S. And I'm running out of time, but I think the next slide may be the end of it for today. So the draft 00 actually was posted just recently, just before the meeting started today. I'm taking the editor role in this, so I'm welcoming constructive contributions from the TSV working group mailing list. Already has contributions from a lot of folks. It's not all my text. It's come from a lot of different folks. And I think the mailing list would be a great way to make progress on this. And the open question is, would the chairs consider holding an interim meeting to continue the evolution of this document? So that's it for me.
I think the answer general is we consider holding interim meeting, relaying a few comments from Jabber. FQ, I think that the upshot is FQ is not perfect. If a couple of flows are in the same tunnel, FQ is going to treat the tunnel as a single flow, and you make it interference for that reason. In addition, you have the possibility of hash collisions in the birthday paradox, because FQ tends to be based on hashing flow IDs and flow identifying information.
Fair enough. Yeah, that's true.
Okay, Bob wanted to say something.
Just in response to that, but that's not an L4S specific thing. FQ's got that problem for other congestion controls generally.
Right, but it's an opportunity for FQ to have opportunity for L4S to have an encounter with RFC 3168 traffic even when FQ is around. I mean, it's
yeah.
Greg Greg put a nice quick summary on the slide, and when you get into details, it's not perfect.
Yeah.
All right.
Okay.
All right. Any other comments on this? All right, we'll watch for the new draft. Okay. Hang on. All right, time for HPCC++. Rui, do you want to turn on your mic, or here we will? And there you go. Whoops, what just happened there? Hang on. I think Meetecho decided to not share your slides. Let me see if I can fix that here. There we go. That should work.
Okay.
Let me know when to advance.
Okay. Should I get it started?
Go. Yes, please.
Okay. So this is Ray Miao from Alibaba Group. This is my first time here. So this is our first submission to introduce HPCC draft. So here today I want to just give a very high level description and with a very illustrative slides, and we will talk about some of the technical details in the later sessions. So this is a joint work with Intel and also Manox. Yeah, please continue. So here we talk about some of the general ideas that cloud operator desired, which is called hyperspeed networking, because cloud today will need have lots of data and also faster computing devices. So there are two trend in the cloud today. One is new applications like high performance storage and also large scale distributed deep learning applications use new hardware that can generate data orders of magnitude faster, so which will require low latency in the network. And the second trend is that the resources disaggregation is happening in the cloud, which is separate the computing and the memory and the storage into different resources pools. So even the memory access will go through the network and also require low latency. So the network is becoming the bottleneck in the cloud. So this is why we desire very low latency networking in the cloud. Please, for the next slides. So to support those applications, silicon vendors continuously generate high-speed chips. We see that those fast networking chips still outpacing the Moore's law. However, the software stack cannot keep up with the speed. So using hardware offloading like RDMA is inevitable. And today, lots of effort has been made to that direction. However, when we have this fast hardware and senders, a network easily become a new bottleneck. Because we run RDMA in our network in Alibaba, we see that we find lots of PFC and also PFC storm in our network. And after a couple months of investigation, we found that it's because the congestion control there is not mature, so that it's vulnerable to congestion and packet losses. Next. So we go deeper into the problem in our cluster, and we found that 3 challenges in our today's congestion control in RDMA networks. So first one is we're facing the PFC storm or even PFC deadlocks. And this is because when we use PFC to prevent packet drops when the buffer is full. But however, if we disable PFC, which is desirable for many choices, because PFC may cause the network storm and the deadlocks. But if we disable PFC, it will cause bad performance because the network cannot converge very fast. So that's a slow convergence problem for today's congestion control. So by the way, the congestion control in RDMA today, we're using DCQCN with Manoc NICs. So the second challenge is if we want to support high throughput application, then we'd like to have a maintained buffer for those applications in the network. However, if we want to support the low latency for other applications, we have to use very shallow buffer even without using buffer. So if we want to support those 2 kind of application in the same cluster, then it's really hard because we don't have so many queues. And also the queues in the network is managed by application. It's not by networking. So the second challenge in that existing congestion control will rely on the queuing. If you don't have a queue, so the network, you cannot tell if there's a congestion there. The last one is existing congestion using mostly using heuristic to guess if the network is congested or not. This require very complex parameter tuning. And for example, DCQC in today's state-of-art congestion control for RDMA has at least 15 parameters to tune. If to tune this parameter in the large production network costs a couple months time to make it stable and and a good performance for applications. Next one. So this is why we propose a new mechanism called a high precision congestion control. Because today's commodity ASICs like Broadcom has in-band telemetry ability. So this in-band telemetry means that switch can add fine-grained network information into the packet so that the packet can carry this fine-grained information and back to the sender. So sender can, based on that information, to adjust the congestion rate, flow sending rate accordingly. So traditionally, those in-band telemetry ability mostly being used for the monitoring and the troubleshooting purpose. We're asking that if we can leverage those in-band telemetry features as a precise feedback for congestion control. So like other approaches like ECN or using RTT for the congestion control, they are just basically the very, very coarse-grained congestion signals. So we're thinking of, if we have very precise signals, can we do better than ECN or RTT-based congestion control? So next one. Yeah, maybe this is a old slides. Can you go next page? Okay, so go before, 2 pages before. Yeah, that's right. Because my colleague sent the slides, I changed it afterwards. But I can talk more about this. So basically, what is in-band telemetry is that the switch can add a very fine-grained information, like what the queue length exactly is, and how many bytes this particular link has already sent out. So if we can get the queue length and text bytes and also timestamp, we can actually know if the link is 80% or 90% utilized, or if it's 100% utilized. So we can get precisely the link utilization. And what we're doing is we don't actually reduce the queue length. We actually want to make sure that the ingress throughput is matched out the egress throughput, so that the link is close to 100%, but not quite yet. So then we can achieve both high throughput, the link is fully utilized, and also low latency, because the utilization is not 100%. So we can achieve both high throughput and low latency at the same time, which it cannot be do today for any existing congestion control mechanism. And then this is very desirable in the data center, because in the data center application, every microsecond matters. So and also that's the case driven motivation for us to go that direction. And also we want to talk about overhead of having in-band telemetry information. We do have a couple of choices. We in our original paper, we're talking about that we add the telemetry information for every single packet. So that's the most extreme case for adding telemetry information. So every packet can get network status and the congestion, the extent of the congestion. Then so you can change the rate very precisely. If you go that way, we calculated the bandwidth utilization is less than 5% for the in-band telemetry data. And if we only do once per round trip time, that overhead is much smaller, like it's around 1 or 2%. And we use very standard telemetry features. We work with Broadcom to implement telemetry features in their Alpha 1.0 standard, and we measure the overhead is about like a 2% in terms of bandwidth. So the bandwidth actually in data center is typically abundant. What is matter more is about the latency. So actually we treat a little bit bandwidth for latency. I think we think that's the fair trade-off. Okay, next. So here we talk about some of the benefit we get if we use the INT as a precise feedback in the telemetry and the precise feedback. So first of all, you achieve very fast convergence. So we know exactly what the sending rate we want to jump to. So the sender can jump to the sending rate precisely. The second one is the congestion control doesn't rely on the queue. So even if you don't have the queue in the network, we can still know what the utilization. So if the operator want to say, I want this traffic to be 70% of the link and use the rest of link for other traffic, that's okay. You can use only 70% of the utilization. The last one is that we only use 3 parameters because every parameter we use has their physical meaning. So we don't use heuristic. We just use the fine-grained load information to calculate the feedback precisely.
Okay,
So,
you should be wrapping up now.
This is the last one. Oh, so we implement in our SmartNIC with the FPGA, and also today we are working with Mellanox to implement its congestion control in their latest NIC, and we compare with the state-of-art DCQC and congestion control in RDMA, and we found that in the first figure we showed that for the different flow size of traffic in the axis, we actually slow down the flow completion time quite a lot. Like for the small flows, we reduce by 95%, and for the medium flow, we reduce by 50%. So we do cut the latency to that much. And the right side showing that the queue length distribution overall in the network. So we see that even we have very bursty traffic, then the queue length distribution is very straight. If you look at the tail, even in the 99th percentile, the network has queue length only 23 kilobytes, which translates to 7 microsecond delay, the queuing delay in the 99th percentile. This is all hardware experiment we done in our test bed. Okay, that's all.
Okay, and let's go directly to the PFC presentation. And there's the presenter. Go ahead.
Hello?
I think we can hear you.
Thank you, David. Hello, this is Huichen Dai from Huawei, and I'm going to present this work, PFC-free low delay control protocol, which is LDCP for short. Next slide, please. Well, at first, I would like to share the current status of LDCP. LDCP has been online in Huawei public cloud and has been safely running for 1 year. It supports Huawei EVS, which is a block storage service with less than 100 microsecond application level RTT. Next slide, please. Well, this is the outline, consists of our motivation of this work, followed by the LDCP algorithms, and then the use cases. Finally, I'll conclude the work if time permits. Okay, today in data centers, it is hosting many cloud-scale applications like search, big data, high-performance computing, and training for AI models. These services are latency-sensitive, bandwidth-hungry, or both. For now, the solution is to use RDMA, as RDMA is able to bypass the host OS stack. It is able to free host the CPU and lower end-to-end latency. These figures reveal that RDMA outperforms kernel TCP in throughput, CPU utilization, and latency. Next slide, please. Well, in the past, RDMA was deployed on special fabrics, which is InfiniBand, but InfiniBand is not compatible with Ethernet, and the IP stack also is too expensive to be deployed in data centers. So how do we deploy RDMA in data center networks? The solution today is RoCE, which is a technique that allows RDMA to run over Ethernet. Next slide, please. But RoCE, I will expand a little bit because this is a problem that we want to address. RoCE v2 performance is very sensitive to packet loss because it does not allow out-of-order delivery. So out-of-order packets will be dropped by the receiver side, and the sender needs to retransmit the lost packet and all the subsequent packets. So the transmission is very, very low efficient. Therefore, RockY v2 uses an Ethernet extension PFC to prevent packet loss. And PFC is a link layer flow control. It simply signals the upstream switch to stop sending if the downstream switch queue builds up. PFC achieves very good performance with RockY v2 when the topology is small and network is lightly loaded, but PFC brings adverse effects as the topology scale goes up, including performance degradation and unreliability. These adverse effects significantly harms latency and throughput performance. And in order to isolate these adverse effects, RockY v2 deployment in data centers is usually limited to only one pod. Next slide, please. Okay, let's look at the LDCP algorithms. LDCP is an end-to-end congestion control that maintains constant low queues. As the queue usage is much smaller than the available buffer size, there will be almost no packet loss. So LDCP allows loss-sensitive transports to operate without PFC. Meanwhile, LDCP does not sacrifice throughput for small queue size, which means LDCP is able to achieve 100% bandwidth utilization. As small queue size reduces queuing delay and packet loss, so LDCP is not specific to RockY v2, but is open to all transports with a reliable service. Next slide, please. Just like TCP has two algorithms, slow start and AIMD, LDCP also has two algorithms. A fast start algorithm that quickly acquires bandwidth in the first RTT, and a stable stage algorithm that maintains low queue and high throughput. Next slide, please. For the stable stage algorithm, the general framework is it uses ECN to signal congestion and let ACK packets to echo the congestion signal back to senders, and senders adjust the window based on the signals received. The updated policy is on the left side of the figure. It's very simple and also hardware friendly. Next slide, please. We also developed a free model for this algorithm. I'm also not going to expand the model, but an important conclusion drawn from this model is LDCP is able to maintain a stable queue size. Next slide. The figures in this slide show that the queue size predicted by the model accurately matches the real queue size of LDCP, and the LDCP queue size compared with DCTCP is much smaller and much more stable. Next slide, please. The second algorithm is the fast start algorithm. As we know, choosing a suitable initial window when a new flow starts up is very challenging, because if we choose a too large initial window, it may cause congestion, which will lead to queue build up and even packet drops. But a too small initial window will miss the transmission opportunities in the first RTT, which will lead to longer completion time for small messages. The LDCP fast start algorithm makes the most of the free bandwidth, but without causing congestion. Next slide, please. Well, in this, it is an incast scenario. If we set the queue limit to 500 KB and each sender transmits 5 KB data, there will be no timeout until 245 incast senders. Next slide, please. Okay, I'll talk about the use cases of DCP. The first use case of LDCP is an implementation with RockY v2. To do this, we revised the RockY protocol a little bit, including adding ACK packets for read responses, and add customized headers. In our testbed experiments, Rocky V2 with LDCP outperforms DCQCN on the various workload types. Also, in our production environment, LDCP also outperforms DCQCN, and more importantly, LDCP runs without PFC. Next slide, please. There are also two ongoing cases. We are also developing LDCP with standard Rocky on Huawei RDMA and also on Mellanox RDMA. So RDMA from different vendors can communicate. LDCP with TCP offload engine is also under development. Next slide, please. Okay, this is concluding. I will leave it on the screen. Thank you.
Okay. So now we get to discussion. Richard, go ahead.
This is Richard. I have one question for the steady state graphs that you have just shown, which I've not seen in the draft, when I read it, obviously. And from the description that you have in the draft, it reads that the stable state algorithm really is very much the fluid model DC-TCP. And what I would like to understand is, why do you see that much lower queue occupancy in the stable state, according to your graphs, than data center TCP?
Okay, first of all, I want to say that we design LDCP from scratch. The most important goal is we want it to be almost lossless by itself, which requires the queue to be small and stable. We find that per ACK, AIMD plus 2 ECM marking thresholds have very strong control of the average queue size. So compared with DC-TCP, which reduce the rate per RTT as the per RTT's granularity, and also uses a cutting edge threshold. So this is the main reason that LDCP achieves much more stable queue than DC-TCP.
So you're basically starting the marking at a lower threshold level with a proportional marking rather than a step change, and
yes.
But then again, it's modeled very much like the only written in the in a paper, the fluid model DC-TCP, which is not, as far as I know, nobody has actually ever implemented fluid model DC-TCP.
Well, as I said, we designed this algorithm from scratch. Maybe it looked like DC-TCP, but it's not.
I just was going to add that there are a number of things in DC-TCP that actually don't work as intended now, and so you don't get as good results as you could do. And some of those things were fixed in Prague to do with the EWMA, the implementation problems, also pacing is done badly. We have offered those patches back to the Linux community, but they've been declined, mainly because sort of DC-TCP, the big DC-TCP users sort of don't want to change it. It's sort of working, but it takes time for them to measure the performance. So yeah, that and Prague also is designed to work with a ramp as well. It's designed to work with a ramp or a step. So there's maybe some similarities here.
Right.
So one interesting questions for discussion is, what should the IETF do in this area? On the one hand, both of these efforts started from Rocky V2, and Rocky V2 is not an IETF protocol. On the other hand, better congestion control is something that we do work on and can work on for other protocols or in a protocol-independent fashion.
So to add to this, So when I read the draft, I'm a little bit unhappy about the signaling overhead again. Basically the same fallback, and even more emphasized than data center TCP is plaguing this particular implementation, but that's not unsolvable, obviously. I do like that this is the first published work, I believe, showing the benefits of the proportional ECN marking and the thresholds. Basically, something that has Bob alluded to for the last 2 years or so, I believe. So I like that aspect, but I'm not clear if this is work that should belong here in TSVG or should be discussed more in ICCRG.
Sure, we can talk it about in ICCIG, but I think it needs to be homed in TSVWG, because it has been an engineering problem now. We already passed the research stage.
Yes, but my understanding is that TSVWG concerns itself with internet-wide deployments of congestion controls, whereas this one is a specific one for data center-wide deployments.
I also noticed that DC, TCP, and QUIC both have been IETF standards, informational standards. So it seems that TSVWG has no limitation whether it is data center scale or internet-wide.
We need to be a little bit careful about that. And I just saw an AD come to the mic. So Magnus, you want to go offer some AD insight?
Some history maybe, but I mean, this goes back from when my previous term as AD, and then when there was a lot of congestion control discussions, especially about around high-speed TCP and things like that. And there we tried to get to the saying that vetting and understanding congestion control algorithms was the work of ICCRG. If something was matured and tested enough, I mean, we can clearly take it on in IETF for standardization, and that hasn't happened to a large scale, but it's we might end up there in the near future. I think again with maybe having need for something standard track, which is working better, but it's not yet, I think. And this works seems to be having the combination of maybe signaling, etc., and what's needed for the protocol works as well as the algorithms. So. And I think the algorithm work in more generalized form probably is first in an experimental write-up is something that ICCRG is a good home for to start with. But
yeah, ICCRG does not have to be sort of the final. The producer of the output document is definitely a place to go work through the congestion control algorithms, though.
yeah, certainly.
Lars, did you want to say something? You came to the mic. We got you turned on.
Yeah, I did. I'm waiting for you to tell me to go. Hey, this is Lars.
Go, Lars.
So as a sort of follow-up to Magnus, right? So this is the approach we had back then, and I think this is still worthwhile. ICCRG can talk about anything congestion control related, and they are. And then we've taken it over and published it through the IETF when it sort of affected our protocols. And that's sort of my question here, right? As you said, Rocky isn't an IETF protocol, and I haven't heard that the InfiniBand Consortium has any interest of, even looking at stuff that we would do or publish. And I'm frankly wondering what they would think if we start publishing RFC says that you should change Rocky like this, or the congestion control for Rocky. So there's an inter-SDO question here. So why isn't this being done in the InfiniBand Consortium is what I actually wonder.
So what I can add. Sorry.
Go on, Mary.
So what I can add here is I think the congestion control mechanism we propose here in data center is not limited to the Rocky. Actually, in our test bed, we showed that we implement our own protocol. It's based on the UDP, but it's not a RDMA Rocky v2. So I think the congestion control mechanism basically allowing us to investigate those control-based mechanism that can be used for the other transfer layer protocols. And we also deploy in TCP as well, and it works well.
Right, so that would be, I think, a stronger case, and maybe I didn't get that from your presentation. I'm sorry, but so I think targeting anything at Rocky is a problem for the IETF to do, since it's not our protocol. But if this is a general mechanism that applies elsewhere, that's fine. It would be, you know, I would still limit it to applying it to our protocols and not people's private protocols. But you know, we can do that. The question really is sort of how much interest is there in the industry to deploy something like this, where we can publish it, but what is, you know, the outcome of that? Is it going to be deployed anywhere? Is there a need for it to incorporate?
Yeah, that's a very good question. I think right now the Broadcom and the Tofino, which is the Intel right now, they support this telemetry function already in their latest chips. Switches, and also the Manox and the Intel already support this mechanism in their latest NICs. So there are vendors supported already. That they're quite interested in doing so.
Can I add something?
Go ahead.
Okay, we're also, as I mentioned, implementing the LDCP algorithm with TOE, which is for TCP, to improve the performance. Also, as you mentioned, that IBTA is not, well, as far as I can see, the congestion control in IBTA is not as active as in IETF, and I cannot find as many experts in congestion control from IBTA as in IETF, especially here. But IETF also, especially for some vendors like InfiniBand and for Mellanox and Huawei, these companies have the capability to implement the InfiniBand or Rocky protocol, but the default congestion control does not necessarily to be what comes with InfiniBand. Like Huawei, we're able to implement our own algorithm, and like Mellanox, in its latest RDMA card, the CX6DX, it provides a programmable congestion control module, which is PCC, that allows us to program our own congestion controls.
The problem for the IETF is a different one, though. It's not the problem is that, you know, we can't really take another standards organization's protocol and like publish standards about it.
Okay.
Right. So in order to do something with InfiniBand, we would need to have an agreement.
But we can get a read of the background, just a congestion control for transports that provide reliable services.
But if the intent is that this applies to Rocky, right, we should first have an agreement with the InfiniBand consortium that they're okay with us doing this work.
Yeah, as of right now, we can't do Rocky work in the IETF. And to the extent that this work is applicable to IETF protocols, it's interesting, and I think further progress in this in IETF would need to focus on applicability to IETF protocols. And this was
I agree.
Black saying that.
So I fully agree here. As a precedent, we do have RDMA protocols in the IETF, for example, IWARP, which are not with InfiniBand encompassing the IPR or anything. And I really like having a more broad change control of the protocol, especially in the signaling layer, if you can have this here in the IETF. But the contentious thing here I observe is the Rocky part, not necessarily the RDMA part. So if that draft could be rewritten as a generic congestion control mechanism applicable to a variety of protocols, that would certainly help.
David, I'm aware that we're actually completely out of time.
Okay, so I think we need to go close it off here. Yeah. Bob, did you have one last final comment before we shut this down?
I was just going to point out that this may not be a problem, but a problem that could occur with the InfiniBand consortium is that if it was done in the IETF, it would have to be open, whereas if it's done in the InfiniBand consortium, it's generally done under NDA, and congestion control is a secret source thing. So it's not an immediately easy thing to resolve. It's two different styles.
Thanks, Bob. I think there's questions about working. There's also questions about how these compare with IETF protocols, whether they complement them, how they interact with them. These are all interesting things, and we can follow them up later. We're really out of time, though, for this particular session.
Yeah, I think we are in fact done for today. Thank you very much.
Okay, my final note is that MapRG is holding an interim next week, so check out that if you're interested in measurements of stuff. And see you at the next TSVWG meeting when we schedule this.
See you then. Thank you.
Thank you.